Hello. So this is Adopt, the query engine which combines worst case optimal join and reinforcement learning. The worst case optimal join performs significantly better than traditional approaches, especially for cyclic queries. The performance of worst case optimal join algorithms crucially depends on the join attribute orders. Thus, we use a search tree based reinforcement learning to find the optimal join attribute order. Here, we'll show you how we use this to visualize what is happening on the back end. So you can see on the left-hand side, users can run all of the visualizations shown here, which you can see which one is selected. We will start with the tree, and then queries can be manually typed into the query box here. So you can type your own queries and be able to run them. And then we also have example graph queries. So you can see we can click on them and they will pop up inside of the custom query box. Or you can use a log file, which is what we will do just out of the sake of time. So we will start with the for cycle txt, which is the EGO Twitter data. And we will start the tree by clicking the start button. And so as you can see here, this is our Monte Carlo search tree that helps decide the optimal attribute order. At each episode, we sample an attribute order, which is a path in the tree, and we measure the performance of this attribute order, and we update the reward along the path. The tree will converge to the optimal attribute orders over time. So at the top left, you can see the number of samples out of the total number of samples, and right below that is the attributes. For each node, we show the maximum and average reward of each load, and the path through the tree represents the attribute order. So you can see 0, 1, 2, 3. So that would be the path. And then we also show the size, which represents the quality of the reward, while the transparency represents how recently the node was tried, which is why these ones over here are completely transparent because they haven't been tried in a while. And then the gray nodes, which you will see flicker around, those are the current paths down the tree that are being tried at the current sample. And yes, that is this visualization. So we'll go to the attribute value view, which visualizes the hypercube. So you can see here at the top left, we can also see the sample number and what it's out of. And then there's the chunk range and the thread number, which right now there are none. But if we hover over a chunk and a thread, it will show which one we are currently hovering over. So the chunk is just a range of values for the attribute inside of the hypercube. So you can see up here, these are the attribute classes, and we have the lower bound for the attribute and the upper bound down here at the bottom. And so the chunk range is just the range of values, and the thread number is shown. You can see them on the boxes as well. And some of the threads are wider than others. So the x-axis is for the percentage of that chunk that is being accessed by that thread. So you can see that thread 2 is accessing this chunk more than thread number 1, 0, 3, and 4. And then at the same time, we can also change the speed, make it run slower. We can pause it by pressing the space bar, and we also resume it by pressing the space bar. And then we can also make it go a lot faster, and it will go faster. And that's about it for this visualization. So if we go to the next one, we can break down the volume and execution time by the attribute order. So you can see at the top left, we have the samples again, and then we also have the attribute classes listed, and they are corresponding to the numbers that you'll see in the legend. So 0, 1, 2, and 3 over here are the same as these numbers up here. And you can see that the process volume breakdown by the attribute right here is not very even. Some of the attribute orders go a lot faster than the others because those are the efficient ones. So you can see 1023 and 1032 are pretty similar, but they definitely dominate the other ones, which you can see that the only thing that varies between them is the last two attributes inside of the attribute order. And then in the execution time, you can see that the very efficient ones are getting more time than the other ones, and the other ones barely are getting any time at this point. Again, we can slow it down, we can speed it up and pause and unpause. And then whenever we hover over the pie chart in the top right of the visualization, you can see what percentage of the pie slice that this pie slice accounts for the total pie percentages, pretty much. So it adds up to 100%. And yeah, that's about it for this one. So we can go to the last one, which is similar to the one we just showed, but this time it's by threads, not by attribute order. So again, we have the samples at the top left and the legend on the left, which shows the current thread number. We can speed this up. So on the right, the execution time is identical for all of the threads because the Adopt Query Engine makes sure that all the threads run for the same amount of time. But the process volume is different by threads, just because some threads are probably running the more efficient attribute orders, which is just coincidental. So there's some slight variance here, but overall they are fairly close to each other. Again, we can change the speed, pause, unpause, and see the percentages when we hover over. And yeah, so that's about it. And I think that's it for our demo. So thank you very much.